I wanted to introduce Sean Webb and myself. I'm John Call from Red Hat. I'm a solutions architect, and Sean is?
I'm the chief systems engineer with Raytheon Technologies on the National Weather Service's AWIPS project, which we'll get into in a second here.
Yeah, that's right. We wanted to come and share with you a little bit today about what we've been doing at the National Oceanic and Atmospheric Administration, and that's an acronym, right? But they've got a pretty fascinating story that comes back to helping keep all of us safe, and so I wanted to talk about their current infrastructure and their migration plan towards OpenShift.
Yeah, so what AWIPS is it's the Advanced Weather Interactive Processing System. It's used to collect weather data, issue weather alerts, produce forecasts, and communicate all that data and information to the public. This is more about what we do in the program. So this is an example of an application that's used to issue severe thunderstorm warnings. So we'd use something like this to highlight where that storm is going to be, generate text automatically, and then disseminate that out to your phones, to the TV, to everything. So this is showing you a good picture of how broad the Weather Service is and their mission and what goes into supporting that. There are over 150 offices, and each of these offices are going to have an OpenShift cluster. There are 122 weather forecast offices. They're the ones doing those tornado warnings, those winter storm watches, things like that. There's river forecast centers that are monitoring river conditions for long-term flooding. And then there's a couple other different office types that would also have these OpenShift clusters.
And so I'll interject here for a moment and say that across the country, including faraway places like Hawaii and Alaska, Puerto Rico and Guam, there's a small footprint of 3 or more computers, 3 or more servers in these locations that need to cooperate to provide the weather alerting information system and to be able to broadcast these alerts to the public out there. So the scale of things begins to multiply and become quite, for me, large. 150 locations, at least 3 servers each, 600 or plus servers deployed out there. And currently the architecture of the deployment relies on virtual machines, and it's time now to modernize it, right? So
past time.
Yeah, it's past time to modernize it. And when I got to know Sean and got to know a little bit about the depth and the scope and the breadth of this architecture and this deployment, my head exploded. So as we've been talking about switching from the virtual machine-based architecture that's currently running today towards the future, we want to be able to continue to run virtual machines while still providing a platform that allows for containerizations of applications, the decomposition of monolithic applications into smaller manageable pieces, aka microservices. But we need to start somewhere. We need to get OpenShift installed in 150 locations on all these systems, and how are we going to do that, right? So we've broken it down into 4 easy steps. There's a core, and I want to ask Sean if he'll elaborate a little bit more about the national...
The network control facility. So those are the AWIPS platforms that basically are at our centralized locations to help us facilitate patching to those sites and log in. We have IDM, for example, instantiated on our NCF system. So a lot of core systems are in that control facility. So.
Right. So it's kind of a hub and spoke model, and we've got some slides that'll illustrate that. But the hub being the core, we need to bootstrap that first, and then once that's bootstrapped, we'll install some services and go forth and build the edge and run the apps there. In order to do all this, we need some automation, we need some tooling, and we're going to introduce a tool that we'll use known as Advanced Cluster Manager for Kubernetes for OpenShift. So let's break it down into steps 1, 2, 3, and 4. Step number 1, or step number 0, whatever you want to call it, is to build out this central facility and to download the installation media because...
Yeah, one of the problems that we face is that we're in a disconnected environment. So at the control facility, what we'll do is we will get the appropriate routes in place so that we can hit Quay, Console, all the content providers, the registries and things.
Right.
And we'll start, and we can at least get the data and the content there.
Right. And in a bit more detail, maybe expanding out upon it. So the installation media, the services that will automate the installation for us from a tedious perspective. How do you install software? You get the CD, you put it in a server. We don't really want to do that 600 times for 600 servers across 200 locations. So we're going to ask Advanced Cluster Manager to do that on our behalf. And we'll show you how that works as well. We'll download all the updates and keep that up to date. And there'll be dashboards for security as well, right? So step number 2 then, after we've built the core, is easy. Just build one cluster and then do it again 150 more times.
So in 6 months. Right. We got a timeline here.
Yeah, there's an impending time frame. But how do we do that? So one of the things that wasn't readily apparent to me as I went through some of the literature is that Advanced Cluster Manager has the ability to consume credentials for the servers that are deployed out into the field. And with those credentials, it can automate all of the tedium, which is to create an installation ISO that contains basic name of the cluster, installation source, those types of basics, and then attach that customized ISO using automation tooling, boot the server, install the cluster, and we're done, right? But don't tell your boss because you need to make sure we get paid by the hour for this.
Right.
So, in addition to that, I just wanted to make mention as well that all of this installation of new clusters can also happen against cloud targets. So in the future when VMware, when AWS, when Azure comes online, we can build clusters there as well. The third step would be after we have the basic cluster installed, there are certain configurations that need to go into securing your environment. And maybe you can tell us a little bit about some of the particulars. Are there particular security ramifications? We talked about FIPS, right?
Yep. We have to install our nodes with FIPS enabled. We'll have DISA-STIGs or other benchmarks applied to not only the nodes, but whatever other services that we're going to provision on this. So yeah, there's definitely a lot of security layers that are required for any government enterprise, but would be good for anybody, but specifically for us, yes.
Yeah, I may pause here for a moment and say that while I really thought about putting some YAML text on the large screen, I consciously decided not to. But turning on FIPS is easy because FIPS is just a yes or a no question when you build your cluster. But the deployment with 3 nodes is unique because it'll be a hyperconverged type of a cluster where the applications and the storage are commingled on the set of servers that are in that location. And deploying out the storage, which is where Karain and I met years ago, is become so easy now that we can just describe how we want the storage to be set up, and the operator that runs inside of the OpenShift cluster will do that for us. There was some consideration that's unique to NOAA because there's a combination of both high-speed NVMe SSD-based as well as traditional rotating media.
Yeah, they definitely look for cost savings. So, for some of their larger data sets, they didn't want to procure, again, 150 times X number of SSDs to handle that storage. So, we gave them some cheaper hard drives to deal with those requirements.
You're saying you don't have an unlimited budget like everybody else?
Right, exactly, yeah.
So inside of the YAML, which I think tried to spare you from showing on the screen here, we simply say that, given these disks that identify themselves as rotating disks, create a storage pool. And then given these other disks that identify themselves as solid state, create a different storage pool.
Yeah.
And when it comes time to build the application, we can target where the application's
Yeah,
going.
we definitely had some performance issues in the current architecture, with trying to write some high volume data to the hard drives, and we actually did have to go and swap in some SSDs to meet that need. So,
for context, the constellations of satellites that are analyzing the atmosphere and taking pictures and temperature readings and things of that nature, as well as the combination of ground-based sensors, culminates in the creation of millions of data points, millions of sensor points per day. So we really could have called this the IoT talk, or we could have called it the edge talk, but it's just a talk about doing cool stuff that is weather related. So we talked about security configurations, we talked about storage configurations, networking configurations as well. There's different network segments for storage and for ingesting data from satellites and pushing that out to consumers. But there's a bunch of networks. We write them all down in YAML, and then we make the tool, ACM, do all the heavy work for us. The fourth is now that we have a cluster deployed, and now that we have a deployed cluster customized and ready to run actual workloads, then finally we go ahead and push out our workloads. So most of the sites run identical application stacks, and I think I mentioned briefly that the applications are virtual machine based. Can you maybe give us an idea of how many virtual machines we're talking about?
Probably about 12 to 14 virtual machines. Yeah, we've got some that'll run a database, some that'll run a storage writer, others that are ingesting that data and decoding it. So yeah, there's a lot of variation to the VMs. And like you said, unfortunately, it's all very virtual machine based right now. We haven't gotten to the work yet of decoupling and containerizing and splitting out these services. So.
Did you hear that groan from the container audience when we didn't say that we had a pod manifest, right? We just have virtual machine manifest. But did you know that? So one of the cool things that has helped, given the budget constraints, given the hardware constraints, I don't think that there's been any allocation of new hardware, right? So we need to make do with what we have, basically, is what I'm trying to say. And OpenShift now for a while has had the ability to run virtual machines, so we're capitalizing on that capability. And the virtual machines are just like pods from a perspective of they get started and scheduled through Kubernetes controllers. So all good stuff there. And then finally, manage and maintain. So I said 4 steps, and here we are on the 5th step. But after everything is deployed, we want to be able to have a centralized dashboard to observe the health of the clusters, the compliance of the clusters, the security of the clusters. So one of our concluding slides is some simple dashboards that illustrate that.
Yeah, this certainly is a challenge, from a centralized position to make sure that all 150 plus, clusters are working correctly and are operational or patched, have their security requirements met, and then so on and so forth. So, yeah. That's
right. So in a nutshell, 5 easy steps to deploy 200 locations. Is there any chance that we can go to the Hawaii location to?
We'll schedule that trip together, yes. We're on it.
But we're excited that NOAA will continue to be able to provide the services which they do, is to alert the general public when severe thunderstorms and floods and those things, they can keep us safe. So thank you for your mission.
Yeah, thank you for all your help.
All right.